Good morning, everyone. Thank you for joining today's webinar, Docker on Windows, from 101 to Modernizing .NET Apps. A few housekeeping items before we get started. As a reminder, this session is being recorded, and a copy of the recording will be sent out after the webinar. We will take questions at the end, so please type them in the Q&A window as they come up, and our speaker will address at the end of the session. I would like to introduce today's speaker, Elton Stoneman, Developer Advocate at Docker. Elton, I will now turn things over to you.
Thank you very much. Good evening and good morning, depending on where you are in the world. Thank you for joining me. I'm just going to share my screen so you can see what I can see. And today's session is about running Docker on Windows. So there's two real parts to this. We're going to talk about the basics of Windows containers and how Docker actually looks when you run it on Windows Server. We're going to see some containers that are running web applications and doing simple tasks and running in the background and that sort of stuff. We'll have a look at the type of images you can get that are out on Docker Cloud that have Windows-based operating systems installed, and how you can deploy your own software on top of that. And then we'll move on to looking at some .NET applications. So we're not using .NET Core here. These aren't greenfield applications. These are old legacy applications that might be running. The sample I've got is a web forms application. You can take that and you can run it in Docker as a container, and that itself gives you a bunch of benefits. But then you can also, it's a jumping off point for being able to modernize your application architecture and add new features by running them in new containers and connecting them all together using Docker. Okay, so those are the two parts of today's webinar. The Docker 101, we're going to walk through how Docker looks on Windows. If you're new to Docker, that's fine. We're going to start with the complete basics. If you're familiar with Docker on Linux, then what I'm going to do is kind of compare the Linux way of doing things with the Windows way of doing things. And then the second part, we're going to look at that application piece. So looking at some .NET apps, looking at how we run them in Docker, and then how we can start breaking up monoliths by running them in separate containers. Okay, so today is mostly demos, but I've got a few slides just to set the scene. So I'm going to start by talking about what the Docker platform is and how the components of the Docker runtime actually work on Windows. Then we're going to have some demos about Windows containers, and then we're going to look at the core developer workflow for Docker, which is you build your application, you package it to run in Docker, you ship it to a shared repository where other people can access it, and then you run your application in a container. So we're going to take a really simple app, see how that workflow works. Okay, so just setting the scene. So there are a few core kind of concepts in Docker which are the same for Windows and Linux containers. The first one is when you package up your application to run it as a container, you actually create it, you package it as an image. So you run a command like docker image build, and you give it a script which describes all the steps you need to take to deploy your application. So that script looks like a deployment script, but rather than being like a classic deployment script that says copy the MSI to the server, run the MSI, click on these buttons. It's in a script called a Docker file, so it can all be automated. So your Docker file describes the parts of your application, which for a .NET app might look something like this. So starting from the bottom, I need Windows Server Core to run my application because it's a full .NET Framework app. And then I need IIS because this is a web application, and IIS is going to be my web server. Then I need a .NET Framework installed, and I need ASP.NET installed and configured so that I can run my app and host it through IIS. And then the top layer there is my own application. So I'm going to copy in whatever packaging format I've got for my own app, and that whole bundle is my complete application. And when I run that through the docker image build command, the output is a Docker image. And that image, logically, is just one very big file that contains the complete file system for my application. So it's got my application, all my application's dependencies, the runtime, and the flavor of the operating system that I want to run it on, all packaged into one unit. And that unit is the portable thing. I can take that unit and I can share it somewhere either private to other members of my own organization, or I can share it publicly. And if it's an open source application, I can use Docker to distribute that to anyone in the world who wants to use it. So those concepts and that Docker image command are the same for Windows as they are for Linux. So for Linux, I've got Docker runs as a service on my Linux box. If I want to produce an image that represents my application, I do the same thing. I write a Docker file that explains all the steps to deploy my application, and I run Docker image build. So in the case of a Java application running on Linux, that might look something like this. Again, starting from the bottom, I'm using Ubuntu as my Linux distribution. I'm installing the Java runtime. I'm installing Tomcat, which is my application host, my application server, and then I copy in my own web application, whether that be a jar file or a WAR file or whatever. And then I run the Docker image build command, and the output of that is going to be an image. And again, that's going to be the package of my entire application. In this case, it's a Linux image, and that's only going to run on a Linux server. But in both cases, the image itself is the portable thing. When I share that to a central registry, the registry doesn't care whether it's a Windows image or a Linux image. It stores them in the same way. You access them in the same way. They're available in the same way. It doesn't matter whether your client is a Windows client or a Linux client. So when you're ready to run your application, you run a command like docker container run, and you give it the name of the image which contains your application file system. When you start your container, it runs the application process. So in the case of an ASP.NET application, it would start the W3 worker process, the executable that actually handles requests that come in from the outside, and it runs that on the host. So you will actually see the W3 worker process, and we'll see this in a demo shortly, running on your host server. But that worker process and the other components that make up your application, they are contained in an isolated unit. So I can have a dozen containers running on my server, and they can't see each other unless I explicitly connect them together and allow them to see each other. So running in the container, I get isolation. So processes outside of the container can't see what's going on in this container. The process that's running inside this container can't get outside and see what else is running on the server. And I've also got a very efficient unit of compute. So my container is running its web server with all its configured units, all its configured software in that single package. But the actual process is running on the host. There's no layer in between like you would have got with a virtual machine. So my container is a very lightweight unit of compute. It's very efficient, it's secure, and it's portable. Now on the Linux side, it's exactly the same. I would still run a docker container run command. I would take my image that I want to run, use that's the name of my image to start my container from. And in this case, I'd have the Tomcat process running on my server. Again, there's a boundary around those processes that make up my application so that the containers can't talk to each other unless I allow that. But the actual process, the actual compute power is coming from the server. Now, because of that, because the host server has to be able to understand how to start and run the process, you can't just take a Windows image and run it on Linux. It just doesn't work. So a Linux server has no idea how to start an exe, even if it could read the Windows file system. So it can't start that application, it can't run that application. What you have to do is you have to run Windows containers on Windows and Linux containers on Linux at the moment. But Docker itself is a cross-platform platform, so I can run the Docker client, the Docker command line in Windows in PowerShell, and I can control a remote Windows server running Docker or a remote Linux server running Docker, and vice versa. Right? If my preference is to run a Mac or Linux as my client, on my laptop, I can control Windows servers running Docker and Linux servers running Docker. So the client side of that is cross-platform. We talk to the API running on Docker. We don't care whether it's being hosted by Linux or Windows. And similarly, the nodes can talk together amongst themselves. So if I were to run a highly available cluster, which in Docker we call a Docker swarm, then I could set up 3 Windows nodes, I join them together in a swarm, and I manage them remotely using the same set of Docker commands, the same Docker command line. And if I want to have a mixture of workloads, so if I have got some Linux parts in my application and some Windows parts in my application, I can mix up that swarm and have a mixture of Linux and Windows nodes. And I still control them in the same way. I'm still starting containers. Docker will decide the relevant node to put them on. So we'll run Linux apps on Linux nodes and Windows apps on Windows nodes. But those containers can all talk to each other. So I can have a distributed application running in a highly available swarm and have all those components running in the optimum runtime for that particular application. And I manage them all in the same way. Okay, so that's the kind of brief introduction. So I'm going to move on now to some demos, and we'll have a look at how Windows containers actually work. So let me stop my slideshow. And what we've got here is a PowerShell command. I'm running Windows Server 2016 in this virtual machine. And if I run Docker version, you'll see what I was talking about with the split between the client and the server. So when I run Docker version, what the command line does is it tells me the version of the command line, so the client, which is running on Windows, and I'm running 17.05, which was the last Community Edition release, and it tells me about the version of the server. So my server is also running Windows, and it happens to be running the same version. But there's compatibility between versions on different platforms, so I could be managing a host that's running somewhere else. Okay, so let's have a look at this first container. So you can run containers in different ways. So the easiest way to run a container is just to give it one task to do. So the container will do one thing and then it will exit. So I'm going to do Docker container run, and I'm going to give an image name I want to use, which in this case is not one of my images. This is a Microsoft image. So this is Microsoft Nano Server, which is the new cut down version of Windows Server that only has a very small API. So you can't run all applications on it, but if you can run your application on Nano Server, it's got a much smaller attack surface. It's got a much smaller requirements for updates. So the likelihood of having an update that needs a reboot is very, very small with Nano Server because there are much fewer features. So I'm going to do Docker container run Microsoft Nano Server. I'm going to ask it to do one thing for me. So I'm going to ask it to run PowerShell and run a single commandlet, write output, let's spell this correctly, write output hello. And when I run that, what Docker's going to do, I've already got that image locally because I've already pulled it. So Docker starts the container. It passes the command line that I passed in my command to the container. It executes that inside the container and it replays the result back to me. So I get my output of hello. So it's not particularly exciting, but that is the equivalent of turning on a server, waiting for it to boot up, writing PowerShell write output hello, seeing the output and turning it off again. So by doing it in a container, I've got an automated process. I can do that really easily, and it starts up in seconds, runs the command in seconds, and then exits. So that's it now. If I do Docker container ls to see what's happening in my system, I don't have any running containers. It's done its task and it's finished. So that particular example isn't very useful, but I use exactly the same approach if I'm running a workshop and I need to spin up 50 virtual machines for the people who are coming to the workshop. Then I have a Docker image that bundles up all the scripts that I use to deploy my virtual machines in Azure. And when I've got a workshop coming up, I literally do a very similar command to that. I do Docker container run with the name of my image that provisions all the VMs and the parameters that I want to pass, saying how many VMs and what location in the world to run them in. And that's it. The container starts up, deploys on my VMs, and then finishes. And I can give that image to anyone who's going to run a workshop, and they can do it in exactly the same way. They don't have any other dependencies other than to have Windows with Docker installed on it. So a task container like that is simple to use, but very useful pattern. So the other way you can run a container is you can run it interactively, which is a bit like connecting to a remote machine. So I'm going to do the same thing, Docker container run, but I'm going to pass some options here. I'm going to say I want to run it interactive, which means Docker will keep it running and let me connect to it. And I'm going to pass a terminal, which means Docker will set up like a dummy terminal for me to connect to the container. I'm going to use a different image. I'm going to use Microsoft Windows Server Core. Again, that's an image that's owned by Microsoft. It's on Docker Hub, so it's publicly available. It's free to use. It's effectively Windows Server 2016 core, so there's no UI, but it gives you almost all the features that you need to run for a containerized application. So it's effectively a clean, fresh install of Windows Server core. And what Microsoft do is they release an update of that base image every month. When there's a set of patch releases to do, they also do a release of the Windows Server image. So when I run this command, I'm getting the latest updates on the latest version of Windows Server. And again, I'm going to pass it a command to run, which is just PowerShell. So what this is going to do is create me a container from that image. Again, if I didn't have the image locally, Docker would pull it down for me. And then it runs my command, which is just PowerShell, and it connects me to the remote PowerShell session, which is running in my container. So here in my container, I've got a cut-down file system. There's not a huge amount of stuff installed in here, but there are a lot of Windows features. So if I run get Windows feature, we'll see pretty much the full set of Windows features available. So this is exactly the same as running this on a remote Windows Server 2016 Core Edition with no UI. So I can see that some of these features have got X in them because they're already deployed. So .NET Framework 4.6 is already installed in the base image, so Microsoft take care of that for me. .NET 3.5 isn't, so if I wanted to install that, I'd have to do something else in my Docker file to add that feature. And most of these are flagged as either installed, which means they've already been prepared in the image by Microsoft, or available, which means you can install them by running a command like add Windows feature, and that will bring that feature into your image if you run that in your Docker file. Okay, and the last thing I want to do when I've got this connected is have a look at the processes that are running inside my container. So there are a few things running here. The only one I'm interested in really is PowerShell, which is the process that I'm running, which I'm connecting to. All the other processes are background Windows processes, which are necessary to start a Windows Server Core instance. So if you're used to Docker from the Linux side, ordinarily if you list the processes, you'll only have one. You'll only have one process that's running your application, but the Windows world is not quite the same as that. So there are a few processes that always run inside the container, and you'll always get a list like this in a Windows Server Core container because some of those key background processes are running inside the container. But the one I'm interested in here is PowerShell. So if I have a closer look at that one, I do get process. The process ID is 3136. And if I include the username, we can see what account this is running under. So there's my PowerShell process. It's not taking up very much compute power. The username is something like user manager, and it begins with contain. If I run who am I can see the full name, which is user manager container administrator. So that's an administrator user that's built into the Windows Server Core image, and that's the default user account for any processes that you start in your Docker image, in your Docker container. So on the host, that actual PowerShell process is running natively on the host. So this is a Windows Server container. So all these processes are in the boundary of one container, but actually I can see them running on the host. So if I were to open another PowerShell session here, and this is not connected to a container, this is connected onto the server. So if I run get process, I'll have a big stack of processes because I've got all sorts of stuff running on my server here. There's far more things running here than you would get on a container. But I can run the same command with the same process ID to have a look at the PowerShell process, and I can see the same process that's running inside the container. So that actual executable is running inside the user space of my server operating system. We'll see that in a second when I run a whole bunch of web servers. But that same process ID is running on the host, but there's no username. And that's an important security feature. So inside the container, the process is running as an administrative account. Now, if there was a defect in the security stack, and someone was able to compromise your application running in a container and break out and try to do other stuff on the host, they can't really do it because the container user doesn't exist on the host. So even if there was a kernel problem and users could break out of a container, they would find themselves in the user space of the server in the context of a user account that doesn't exist. So they wouldn't have any permissions, so they couldn't then go and do anything else. So that's an important thing to bear in mind when you're looking at how these containers run. Okay, so that's an interactive container. So the use of an interactive container is when you're building up your Docker file, it's very useful to be able to test your script first. So you could spin up an interactive container, run through all the scripts that you're going to use to deploy your application and test that it works, and then put those in your Docker file. So the Docker file is the repeatable unit. So every time you build it, your application will go through the Docker will go through the scripts to deploy your application, and the output will be an image that's the same every time. So it's a nice, repeatable, simple format for deploying your application. So you wouldn't want to run an interactive container, build up your application, and then save that image. You can do that, but it's much better if you use it as a test ground to work out your steps to deploy your application, and then actually put those steps in a Docker file that you can repeat. Okay, and the last type of a container is the one that you'll run most frequently. It's a background container, which is going to host a process like a web server or a database or a message queue that's going to sit there and do a lot of background work indefinitely. So you run it in exactly the same way, and you can use these same images in different ways. So I'm going to use Docker container run, same as before. I'm going to pass some new options. So this is detach to make sure that it runs in the background. I'm going to pass a publish option to allow me to send traffic into the container. So by default, the container is locked down, so I can't send like HTTP traffic into the container from the host. So I have to explicitly allow that. And I do that by publishing ports. So I'm going to publish all the ports and give my container a name so I can refer to it easily. I'm going to call it IIS, and then I'm going to run Microsoft IIS Windows Server Core. So again, this is an image that Microsoft own. It's Windows Server Core with IIS already deployed on it. So I can do that. I've already pulled that image down, but if you can run this exact command yourself, and you'll have the exact same output because the image contains IIS and the necessary commands to start up the application server, which is in this case just the default website. So you can run this exact same command yourself and have the exact same output. So my container is running. If I do a Docker container list, you see the only one that's actually running now is my IIS, my web server, and I gave it a name of IIS. So if I want to send traffic into it from on the host, I can inspect that container, and I can see that it's got a few things that make it useful. So it's got like a virtual IP address, which has been assigned by Docker. So when I'm looking at my machine locally, I can browse to that virtual IP address, and there's my default website from IIS. So again, that's not particularly useful to see, but that's going to keep on running now until I stop it. If I was running on a highly available cluster, a Docker swarm with several machines, if there was a problem with one of those hosts and the host went down and it took my web container with it, Docker would see that and it would start a replacement container somewhere else. So having a background container that's meant to keep on running allows you to get that sort of availability. Okay, so those are all images that I've got from Microsoft. So Microsoft own those, they manage the deployment timescales and all that sort of thing. Of course, I can also build my own images. So let me show you how that looks with a really simple Docker file. So incidentally, all this code is going to be up on GitHub, so I will tweet after the event to show you where you can go and grab that stuff. Okay, so I've got a really simple ASPX page. So this is an ASP.NET web application, but it's only got one bit of code in there, which is to display the machine name of the host that's running it. And the rest of it is all HTML that's going to show that machine name. So if I want to take my application and package it in Docker, then I write a Docker file. So I'm using Visual Studio Code, which has some nice highlighting for things like Docker files that I'll be showing you today. You can just write this in any text file. So I've got 3 lines in my Docker file to make my application work. The first one is an escape directive, which tells Docker to replace the escape character instead of being a backslash to being a backtick. So all that means is that in the early days of Docker, it came from Linux, and in Linux, the backslash is typically used to break across multiple lines. Whereas in Windows, we use it for path separators. So we can't really have, if I weren't to include my escape character, then Docker would think these are all part of one line. So the escape character is just to make it more Windows friendly. So when I've got running PowerShell scripts inside my Docker file, I can break over multiple lines and use a backtick, which is what PowerShell uses. And then the from instruction is the only one you need to have in a Docker file. And this one's saying that this is the image I want to base my image from. So I'm going to start from Microsoft's ASP.NET image. So this is ASP.NET with IIS installed running on Windows Server Core. So this is full .NET framework. And then the only thing I'm going to do to customize it is to copy my default ASPX page into the root directory of the web application. So that's the default root directory. I know it will be there at that location because that is one of the facets of this image. So by knowing how this image is deployed, I know how to use it. I could do this differently, and I could start from Microsoft Windows Server Core, and I can manually install IIS and install ASP.NET inside my Docker file. Docker doesn't care what I do, so I can have a business rule that says we always go back to Windows Server Core and we deploy everything from scratch. Or I could have an alternative rule that says we use the most relevant base image to minimize the amount of work we do. So in this case, I'm using a base image that gets me most of the way there. So to build my application, I don't have to do very much. Let's copy the path and I'll show you the commands. So let's clear this down and change to the right directory. So in here, I've got my Docker file and my ASPX file. So that's everything I need to build my image. So to build it, I run docker image build, and I give my image a name, and my name is a tag that I can use to uniquely identify my image when I share it somewhere public. So in my case, I'm going to share it on Docker Cloud, which is a public registry for people's images, and my username on Docker Cloud is sixside. So I start my image name with sixside, I'm going to call it hostname app, and I'm going to build in the local directory, which is what that dot means. So Docker's going to execute all the steps in that Docker file, and as it happens, I've already built this image before the webinar started, and so all the steps that Docker executes, it can get from the cache. So the image that Docker uses, it actually creates it in layers, and the layers can be shared between different images. So when I have a Docker file with a set of instructions, what Docker does is it looks at each instruction, it compares it to the cache to see if it's already got a layer that represents the same thing, and if it has, then it reuses it. So in my case, I haven't changed the Docker file, I haven't done anything new, so I'm going to be using the cache for all the steps from my Docker file, which means that it happens really, really quickly. Okay, so I've got my successfully built image that's been tagged with my hostname app, and if I want to now, I can share that. So I can do Docker image push sixside, let's spell my username correctly, sixside hostname app. And what that's going to do is it's going to take my local image, because at the moment that image only exists on my server, and it's going to push it up to Docker Cloud, which is a public registry where anyone can go and get it. And you can see here about the layers that I was saying about. So each of the components of the application is actually a separate layer, and the caching that works with on my local server to reuse those layers also applies to the registry. So when I push my image up to Docker Cloud, it says some of these layers already exist, so I can reuse them, and the only one that's relevant is the one that's specific to my application, which is actually the contents of my ASPX file. So it's pushed that layer up now. So if I browse to Docker Cloud and go to my repository for my hostname app, so I've got a whole bunch of repositories on here because building images is something I do every day. So if I filter that, we'll see my hostname app is here, and it was last pushed a minute ago. So the Docker Cloud, which is like an evolution of Docker Hub, is a place where I can store these images. This happens to be a public one, so you can go and pull this yourself, run it on your Windows server. And all Docker Cloud is doing in this case is hosting the image that I've pushed up. So it knows it's a Windows image, it knows I've pushed it recently, and if I had lots of different versions, I would see them all in these tags. So I could tag my image as version 1, version 2, version 3, and push them all up in Docker Cloud and make every version of my application available to anyone who wanted to use it. Okay, so I've built my application, I've used my Docker file, I've got my image. So now I'm ready to run it. So if I clear this down, I'm going to run a single container from my image. And again, it's the same process. I'm going to do Docker container run. It's a web application, so I'm going to run it in the background. And it's got some ports that I need to map. So I'm going to do that by publishing all the ports to my local server. I'm going to give it a name. I'm going to call it app. And the image name this time is sixside hostname app. So the command I'm running is exactly the same as when I ran IIS. The only real difference is the name of the image. So previously, the IIS image was called Microsoft/IIS. So I know that's a repository that Microsoft owns. So I can't push to that repository, but it happens to be a public one, so I can pull from it and run that application. So that big long identifier is the container ID, which is just a random ID that Docker generates. I've also given my container a friendly name, so I can do the same inspect command as before, Docker container inspect app, and I can get the IP address of my custom application. So when I look at this is going to show me my custom code instead of the default IIS website. Now, when it hits the container, the first thing it does is spin up a worker process to handle the request. So that's why there was a lag of a couple of seconds there. But then it goes straight into my ASPX site, and all it does is it gets the machine name from the current environment, which is a random machine name, which happens to be the container ID, and it displays it on the page. So here, when I looked at my container, if I do a container list, you see I've still got my original IIS container running, so I haven't stopped that. I've got my hostname application is running with container ID that starts 2A99, and that is the hostname that the application sees inside the container. So when the app's running in the container, it thinks it's running on its own server. It's got an IP address, it's got a host name, it connects to DNS, it can reach other containers by accessing by the container name, but actually it's in an isolated unit, which is a container. So other machines, other containers can't access this one unless they do it through the published ports. Okay, and this is a very lightweight unit. So I'm going to run several copies of my web server now by using a loop in PowerShell. So I'm using exactly the same command, docker run, detaching and publishing all, and using my host name app. But I'm using 5 times. So it's going to create 5 containers. So they all started fairly quickly, and I can copy in another loop to open them all in the browser. And then we'll see that they've all got separate host names coming from the container ID. So let's close this down. Again, they'll all have a short startup time, but then when I browse to each one of these, it's exactly the same application, but each one has got a different host name because they're each running in separate containers. So that's showing me that I've got all my application is the same, but the configuration, the environment is different for each container because they each think they're running in their own server. Now back on the real server, let's go back here. So let's clear that through. So I've got a whole bunch of containers running now. I've got my original IIS container, I've got my application container that I started, and I've got my application containers that I started in loop. So if I do a get process and look at the web worker processes, we'll see that I've got 6 of them. So they're all from my custom application. The original IIS application doesn't use the worker process. So I've got all those application worker processes that are serving my ASP.NET app. But if I look at the host here to look at the IIS service, we'll see that IIS isn't running on the host. So everything my application needs, including ASP.NET and IIS, is packaged in the image. The host itself doesn't need any of that stuff. So my host is a dev machine. I've got various bits and pieces installed. But if this was a production machine, I would have Windows installed and Docker and nothing else. And everything I want to run in my applications comes packaged in my Docker image. So when I run my container, the W3WP exe exists inside the image. It doesn't need to exist on the host. So even though in my case I've got IIS installed, it's not running, but all these applications are using their own copy of IIS running inside the container. Okay, so let's switch back to my presentation for a second. Okay, so looking at this demo, just showed you briefly how this stuff works, how these containers look, what an image looks like, how you can share an image by pushing it somewhere centrally, and then bring it down and run your application in a container. So the container itself is a really lightweight unit. It's efficient and it's portable, and that's why a lot of people are coming to Docker. So the efficiency means you can run your applications on a much smaller set of infrastructure. The portability means you can run in-house or you can run on any cloud. And the applications that you run will be the same on your laptop as they are in your test environment and your production environment. And then there's a security aspect. So I only showed one small part of that, but because these containers are isolated, there's a security layer over and above what you would get by running lots of applications side by side on your machine. So containers can't interfere with each other. And even if you could compromise the container and break out, there's not much you could do because you'd be running effectively in a user space with no permissions. Okay, so that was the kind of basic introduction. So we've seen a bunch of containers, we've seen roughly how that works, we've seen one very, very simple Docker file. For the rest of the session, I'm going to be looking at a slightly more established application, a .NET application, and seeing how you can take an old app and run it in Docker without having to change any code. So the first thing I'll do is I'll take an MSI, so that MSI might come from an existing build process that has been run from hundreds of lines of MS build script that you don't want to change, and it produces this MSI, and you can take that and you can put that in your Docker file and move your app into Docker without having to touch the code. But the second thing I'll show you is if you do touch the code and you do start making changes, once you've moved to Docker, it's really easy to start breaking features out from a big monolithic app and bring them into separate containers. And that means that different features can have different deployment cycles, and the testing that you have to do when you do a release can be isolated. So if you only release one feature that's running in one container, that's the only thing you have to test. So you can release more quickly with less risk because you're sure that what you're deploying is what you've tested in your environment. And then very quickly, I'll show you a tool called Docker Compose, which is how you describe a distributed application that runs across multiple containers. Okay, so very briefly, this is version 0 of the application. It's a simple web forms app that talks to a SQL Server database. If I'm a developer and I join the team and I want to start running this app locally, I need to install Visual Studio to build the application, IIS to host the application, and SQL Server to run my database. So I've got a setup time which is going to take possibly days before I'm productive. The first thing I'm going to do is take both those components and run them in containers. So I'll have one container for my web application and one for my SQL Server database. Now, my container could talk to a SQL Server database sitting on a server somewhere. It doesn't have to be in a container, but by using a container, that makes it really simple to deploy this stuff in a development environment, in a non-prod environment. So version 1 is going to be the same app running in Docker. And version 2 is going to take take one feature out of the application and run it in a different way. So I'm going to take some code out and put it in a different component that's going to run in a different container. And I'm going to use Docker to plug those things together by running a fantastic off-the-shelf Docker image that's got a message queue in there. So I'm going to put a message queue in between my two features and let that deal with any peaks in load that come through. They'll get smoothed out by the message queue. And then once I've got a message queue in there, I can add other things as listeners to my events that get published. And so I can add very easily a reporting stack. So I can have a secondary database that's used for reporting. I can leave my SQL Server database for transactional data. I can add a reporting database which might be NoSQL. In this case, I'm going to use Elasticsearch. And I can point an analytics tool at my reporting database. So I can let users do their own sort of analytics without having to come and query the IT department to get some results from SQL Server. Okay, so we're going to have a look at those iterations and start with the simplest. So back to my Windows server. Okay, so here in part 2, I've got a new Docker file for my .NET application. So this is how you would get one of the ways to get started if you've got an existing application and you want to see how it looks in Docker. So this is slightly more involved than the previous one. It generally comes to sort of 10 lines, including white space. So it starts in the same way. I'm escaping to a different character, so that makes it more friendly for PowerShell. I'm using Microsoft ASP.NET as my from image, so that's the image that I'm going to be based on. And I'm being more specific this time. So previously I've just said from Microsoft/ASP.NET, but this time I'm pinning it to a specific version of a specific release of that image. So when Microsoft do an update of their base images, they don't get rid of the previous ones. So I can pin my Docker image to a specific version of Windows. This happens to be, I think, the April release. And I can say that whenever I build my image, I know it will always be the same because I'm pinning it to a specific version of the base image. The next command says that for the rest of my Docker file, I'm going to be using PowerShell instead of the default batch command. And then from then on, I'm start building up my application. So these are kind of boilerplate things that I need to do to configure my Docker image. The next thing I do is I run some PowerShell to turn off the DNS cache in Windows. So the reason I'm doing that is because this application is the web application. It's going to talk to a database. The database is going to happen to be in a container. So when my web application looks at the connection string and it finds the server name for the database, that server name is actually going to be the name of a container. And what I want my application to do is come to the DNS server, which is running inside Docker. So the Docker platform has got its own service resolution. I want my web container to come to Docker and ask for the IP address of the database container. And that's fine, that's all done for me. But Windows has a slightly aggressive DNS cache. So if it comes to Docker and asks for an IP address for a container that doesn't exist yet, it will cache the fact that there is no response and it won't come back again. So all I'm doing here is turning off the DNS cache to make sure the container always comes back to Docker to get the most up-to-date IP address for the service. Okay, so the entry point command is the next one. That tells Docker what to do to start a container from my image. So the image is just a static file system with everything you need to run in there. But also as part of the image, there's a point to tell Docker what to do to start the application. So when I do Docker container run, what Docker will do is start the PowerShell command inside a container and point it to this script, which is a bootstrap that's going to start my application. And then I copy in that bootstrap script. So the source is wherever I run my Docker command. So on my laptop in this case, but it could be on a CI server. And then I copy in the MSI. So this is the MSI from my existing build process. This is my current build output. I copy that into the container, and then I run start process MSI exec to deploy the MSI file. So I'm giving it the parameters to tell it which MSI to install and to do it without popping up any windows. And then I tell PowerShell to wait until that's completed. So that's all I need to do for my Docker file. If you've got an MSI that's going to deploy a web forms application, these 10 lines are going to get you there and have it up and running in Docker. Okay, so it's the same process as before. If I copy the path, and let's clear this down. I'm going to get rid of all the containers that are currently running because I'm running a bunch at the moment. So I'm going to do Docker container RM, removes containers, and F is a force flag. So it's going to get rid of them even though they're running. And I'm going to pass it a list of all the containers. So that's going to go through and stop and kill all my containers. Okay, so let's change to the path for my Docker file. And in here is my Docker file for my web forms app. There's the Bootstrap script that I copy in, and there's the MSI, which you can deploy my application. And the way I build my image is exactly the same as the way I built my previous image. It's slightly more complicated, but the actual command is the same. I'm going to do Docker image build. I'll give it a tag. I'll call it web, and I'm building from the current directory, so the path is just dot. And again, I've already built this, so it happens really quickly because everything comes from the cache. So all those individual instructions, Docker's compared the content of the instruction to the cache, and it's found that it's already got layers that match, so it's just going to reuse all of those layers. Okay, so I've built my new container. Now what I need to do is this application uses SQL Server. I don't have SQL Server installed on my machine, so I'm going to run SQL Server in a container. So I'm going to copy that command line in and show you what it does. So it does the same as before. I'm running a container. I'm using the short form of the options here. So I'm detaching the container and I'm publishing a specific port, 1433, which is the SQL Server port. Give my container a name, and this is important because this is the name that's in the connection string for the web application. So when the web application looks for a server called DB, it's actually going to get the IP address from my container that's called DB. The -e is an environment variable. So most containers for modern applications use environment variables for their configuration. The SQL Server container needs you to accept the license agreement, even though it's SQL Server Express, and that's what that environment variable does. The other option passes the credentials that I want to use for my my administrator account. And the final part is the name of the image. So it's Microsoft SQL Server Express, and it specifies Windows because now you can run SQL Server on Linux, but that's a different session. Okay, so I've got that running now, and now I can run my web container too. So I'm going to do Docker container run, detach, and publish all. So you can use the short form or the long form of these options, and I'm going to use the same environment file which has my database credentials in there, so that when I connect with my connection string, I'll be using the same admin user account and password. And my image is called web. Okay, so that started that container. So now I should have two containers running. So I can see those. I've got my SQL Server container and I've got my web container. And if I have a look at the details of the web container, and I can use the container ID or the name, and I've got the IP address. This is the IP address of my new application. So let's clear down some of these guys here, and I'll browse to my new application. And the first thing I'll see when IIS is up and running is I get a forbidden access error. Now that might be unexpected. It's expected for me because I know what's going on here. But if I see that when I've moved my app into Docker, the first thing I'll do is I'll go and look at my Docker file, because this is telling me that IIS is running, but there's nothing listening at the default location. So there must be something somewhere that's configuring a different location. So I go back to my Docker file, but the problem is it doesn't tell me very much about what's happening here. So I can use an MSI. If I've got an MSI from an existing process, I can use that to deploy my application. But the MSI is opaque. It could be doing anything at all. So in this case, it's setting up a specific web application, a virtual directory, but I can't see that because it's all baked into the MSI. So This is a good starter for 10, but there are potentially issues with just taking an existing MSI and putting it into a Docker file. And one of those issues is you can't see what's going on, so it's hard to kind of debug problems. You'd have to go back to the source of the MSI file, which in my case is a kind of 200-line Wix XML file, to find out that the virtual directory is called product launch. Okay, so I'll put in the correct virtual directory, and now that's going to talk to my web application, and it's going to spin up the W3 worker process, and it's going to do a whole bunch of other things. So this application, the reason why this is taking a while to start up is because when I first run this application, it uses Entity Framework code first. So it's going to connect to SQL Server, assuming that the SQL Server container is running, and the first thing it's going to do is deploy the schema for my application, and then it's going to deploy the seed data for all my for my default data, and that's what's going to take a little while to do. And because of the way I've written this particular Docker file, the first person who hits that lag is going to be an actual user, an end user. In this case, it's me. So when I click on sign up, this is just a sample application that's on GitHub. It's on GitHub Docker samples. It's an ASP.NET Web Forms app. It's like a sign up for a newsletter, a fake newsletter. You can put in all your details here. So let's put these in. So Elton, I'll put in my real name and the email address. Feel free to get in touch with me. So I'm in the UK at the moment. I work for Docker Inc. and I'm a dev advocate. Okay, so when I click on Go, that's going to save that data in SQL Server. Now I know that the connection to SQL Server must be working because these drop-downs come from seed data in the database. So I know my database must have been deployed, the seed data must be there, otherwise I wouldn't see those things. Now how do I know that I've actually got data in my application? Well, I can check that too. So because let me have a look at my containers. So because I've started my SQL Server container and mapped the ports, I could connect to SQL Server in a container using SQL Server Management Studio. So I could do that just like I would normally connect to a remote server. But I can also run a command inside the container. So I can do a docker container exec to execute command. The container name is DB, and the command I want to execute is PowerShell, and it's going to be database query. Let me go and copy this because I can't remember what the syntax is. It's invoke SQL query. That's invoke SQL query, and the command is select star from prospects, and the database is called sign up, I believe. Oh, spell that correctly. So this will either give me the output or it will tell me that I've given the wrong PowerShell command name. Invoke SQL command, I think it is. And this is called query. There we go. Okay, so when you get the command right, what you do is you execute a command inside the running container. It leaves it running, so I've still got my SQL Server container running, and other clients can still be connecting to that. But it invokes that SQL query, and it shows me the output. So when they packaged up SQL Server to run in a Docker image, Microsoft have provisioned the SQL Server database engine, but they've also applied all the PowerShell commandlets. So from outside the container, I can execute invoke SQL command when I remember the name, because I know it's been deployed inside the image. So I can execute these queries from outside without necessarily having to publish the port. So I could lock down my SQL Server container so it's only available through Docker. Okay, so that's fine. I've got a fairly basic version of my application. It's up and running. It's running in Docker. There are a few issues with that. By using the MSI, I can't really see what's going on. So the next version of the application, it doesn't use the MSI. It goes back to the source. So the source code for my application is all up on GitHub, and the version 2 of my web Docker file is a little bit more involved. There's a bit more going on because it's given me a much richer experience with Docker. So the first thing I'm going to do is let's show you the Docker file for the application. So I'm still starting from Microsoft ASP.NET, and again, I'm putting it to a specific version, but I'm using a more recent version. So this is how you would do a Windows update in the Docker world. You wouldn't connect to a container and run Windows Update. Instead, you build a new version of your image, you test that, and when you're ready, you get rid of your old container and replace it with a new one. Again, if you're running in a highly available Docker swarm, you can do that with no downtime because Docker will manage the rollout for you. I'm switching to PowerShell again so I can run PowerShell commands, and I'm turning off the DNS cache to make sure that Docker always serves up the latest IP for a container. And I'm now getting rid of the default website this time. So rather than have things sat in the default website, I'm specifically creating the setup that I want. And I create a new directory and I create a new website for that directory. So I can see here that I'm using port 80. I can see that my directory is it's called web app, but there's no virtual directory. So I can see this I can expect to see this from the root location on the server. And I know this path will always exist because I'm creating it up here. So I'm building up a known set of deployment for my application. So then I've got my entry point with my PowerShell script again, and then I copy in my PowerShell script and I copy in the output of my web application. So this line here is the interesting one. So instead of using the MSI, I'm copying in a published website. So this is the same as doing like an Xcopy deploy, when if I was to right-click from Visual Studio and do publish website, I would get my published web application, and that's what I'm copying into my Docker image here. But I'm not using Visual Studio. What I'm doing is I'm using a builder step inside the same Docker file. So if I roll to the top here, before my image starts, I've got some more lines in here which are compiling the application. So this Docker image is starting from MS Build, so that's an MS Build image that's up on Docker Hub. It's already packaged with web deploy and everything you need to compile your application. It copies in the NuGet package config and does a NuGet restore, and it copies in the rest of the application source and does MS Build. So it does MS Build and it deploys using the Visual Studio web targets. So what that means is anyone can compile my application from source without needing to have the right version of Visual Studio or any version of Visual Studio or even .NET. If I've got a completely fresh Windows server with Docker installed, then I can do a Docker build image using this Docker file. And the first thing that server will do is it will download the MS Build image, then it will compile my application, and then it will download the ASP.NET image, and it will package up my compiled application from the earlier stage in the Docker file. This is really powerful if you're using continuous integration. You don't have to set up a build agent that's got a whole bunch of complex dependencies. Your build agent just disappears. This is your build agent here, and all you need to run this is a server that's got Docker installed. So that's really powerful as you start building up complex deployment pipelines with lots of different components. And the last thing that's of interest here is I've got this health check command, which is also different from the previous Docker file. What this health check does is it tells Docker how to test that the application running inside my container is still healthy. So this is a web application, so all it does is every 5 seconds, Docker will fire a PowerShell command that runs inside the container. And inside the container, it will make a web request to the local host. So it can run inside the container, it will access local host. And if the response is 200, then it tells Docker that everything is okay. So return 0 means the application is healthy. If there's any other status code or there's an error, then it returns 1 and Docker knows the application is not healthy. And what it can do in that case is, again, if we were running in a swarm, it would stop this container and it would bring up a replacement. So that's excellent if you've got a badly behaving application that's a legacy app that you're not going to fix. And what you currently do is you restart the web server every night, or you recycle the worker process on an hourly basis. Docker will take care of this for you. It will restart the container if it's not functioning correctly. And the last things are some environment variables. So this version of the app is using a message queue to persist data. So instead of the website talking directly to SQL Server to insert a new row, it drops a message on a queue. Actually, it publishes an event to a queue, and then it comes back, and that's it. It doesn't talk to the database to insert data. And what that means on the other side of the message queue, there's another component which is going to save the data. So let me start this application, and then I'll show you how that looks. So let's get rid of everything that's currently there. So let's do a Docker container RM again. Okay, yeah, if I go back to, let's go to V2. and in here on Docker Compose. So Docker Compose is a tool that takes that allows you to describe a distributed application. I'll have a look at this Compose file in just a second. I'm going to deploy version 2 and say up-d, and that's going to create me a whole bunch of containers. So to create me a database container like I have previously, it would create me a web application container, a message queue, and a save handler. So what's happening there is when for version 2 of my application, what I've done is I've changed the code for saving people's data. So instead of, let's go to the sign up page, what used to happen in version 1 is when you click that save button, then the application would open up a connection to SQL Server. So that would come from the connection pool. It would look up the objects for the drop down boxes, and then it would insert the new row and save the changes. So while this is happening, although I've got a using statement, so it's all going to be as efficient as it can be, for the duration of this, which is 3 separate SQL statements, it's going to hold open a connection from the connection pool. And that's fine because it's only going to take half a second or so. But if I've got thousands of people concurrently trying to do this as part of a marketing drive, they all hit my website at the same time, then what I'm going to do is I'm going to exhaust the database connection pool, and my users are going to start seeing errors. So this doesn't really scale. I could throw lots and lots more web containers, that's fine, but all I'm going to do then is turn the bottleneck into SQL Server. So my users will see errors about not being able to connect to SQL Server. I'd have to also scale SQL Server, which is a more complicated and expensive proposition. So what I'm doing in version 2 is I'm taking the same data, but I'm just publishing it to a queue instead. And so I'm saying, here's an event, a prospect has signed up, and then that's it. The website returns straight back. And on the other end of that queue, I've got a new component, which is a message handler, which is just a .NET Console app. And that .NET Console app uses that same message queue class to create a connection. It subscribes to the type of event that's being published by the web application, and then it sits there waiting for events to come through. When it gets an event, it writes some output to the console so I can see what's happening. And then it uses the exact same code that was previously in the website to insert the data into the database. So what this is doing is saying, I'm using a message queue to buffer the input from my web application. So if I do get thousands of people all connecting at the same time, the queue might fill up, and it might take a little while for the handler to get through them all and save them to the database, but that's fine. The end users aren't going to see errors. They're not going to be exhausting the connection pool because the connection pool is being managed by my message handler. Okay, so let's have a look at this now. So if I clear this down. So let's have a look at my containers. I've got my database container, my web container, my message queue, which is called NATS, so the message server I'm using is called NATS, and then my save handler, which is listening on the other side of the message queue. So I've got a new web application container, so I need to find the IP address so I can connect to it. If I was coming from outside this machine, if this machine was a server running in Azure, then any external traffic would go straight into my web container. But when I'm running on the machine, I need to get the IP address to direct the traffic in. So Docker container inspect 06B. And the IP address for this one is 192.168. Okay, so let's browse to that. Okay, so we've got a new version of the application with a fancier UI and a blatant advert for DockerCon in Europe, which is coming in October. The interesting thing about this is I've got a completely new database container too. So I've lost the data that was previously in my container because I wasn't storing that externally. But I didn't have any lag when this started up, and that's because of the health check. So when the health check first kicked in, it made the first request to the worker process to spin it up, and that was what deployed the schema to the new database and deployed the seed data to set this thing up. So now I've got my new version of my application running, and the health check is running to make sure that it's always healthy, but it's also acting as a warm-up, so the first actual user doesn't hit a cold application server. If I was using like expiration and caching in my web application, then it would also, the health check would also make sure that my caching was kept up to date. Okay, so let's just put in some data in here, click on go, and it works the same way. So from the user's point of view, it's the same thing. But what I can do is if I have a look at my save handler, so if I look at the logs for 49, then I'll see the log output from my console lines. So it's listening for messages coming in. It's receiving a new message for the prospect sign up. it sets the configuration for the database, and then it saves the prospect, and there's the prospect ID. So that ID is an identity column from SQL Server, so I couldn't have got that unless I've saved my data. So it's all still working in the same way, but now I've got a much more resilient infrastructure. And it gives me the opportunity to do some more interesting things like this. So in version 2, I can add a few more things to my compose file. So the version 1 compose file describes my database, and my message queue, and my web application. And all these services are doing are effectively collecting the options that I would pass to the Docker container run command. So this setup in my Docker compose file is the same as my Docker container run when I ran my SQL Server container. I've got my save handler in there, but I've got a few extra things. I've got an index handler, which is a separate .NET console app, which is listening for the same images, but it's putting them onto Elasticsearch. So I've got Elasticsearch running in a container. And I've also got Kibana, which is going to be my analytics front end. So I can easily upgrade my application, let's see where I am, by doing a Docker compose. The file this time is version 3, and it'll say up-d. And what we'll see here is that Docker Compose, it compares the running application to what's defined in the compose file. So you can see here that I don't have the latest version of the index handler, but it's pulling that from Docker Cloud. So this is a public image that you can run yourself. So all I need to do to give someone else access to the application is give them this compose file. All the images are public, so anyone can grab this compose file and run Docker Compose up, and they would get exactly the same experience as I've got from running this. So now, when I run my containers, we will see I've got a whole bunch of other things running here. Now, there's lots of different applications with different stacks. Some use Go, Java, Node.js, .NET. There's a whole variety of different things here. I'm going to manage them all in exactly the same way. And what we'll see is that Docker did not start a new web application. So it saw that the configuration for the web app hadn't changed. So my web container is still running. And now if I put some more data in here, and just put some 3s, we'll see the behavior is exactly the same. It still works in the same way, but I've got something else running here. So if I have a look at the Kibana container, Kibana is 598. I've got another web application running in another container. So if I browse to that, and port 5601, which is the Kibana port. So this is a front end that sits on top of Elasticsearch. This is a public image. I haven't got to do anything to add this to my application. And by default, it expects to talk to a container called Elasticsearch, which is what I've got in my Docker Compose file. Because I've already put some data in there when I added that last prospect, it's already got all these fields. And then when I click on Discover, it can show me the basic details of the event that's just been published and listen to from that separate event handler. And I can also do analytical stuff like adding pie charts and graphs and all sorts of stuff here. Okay, cool. So that's the end of the demos. And that was my modernized .NET app. So there are a couple of things that are the key kind of takeaways from today. So the first thing is we've seen just a small fraction of what Docker can do. Docker's a mature platform. It's been around for over 4 years. It's new to Windows, but it's not new to the rest of the world. So the vast majority of the Docker code base is the same on Windows as it was in Linux. And it's easy to Dockerize your apps. So that first Docker file I showed you with the MSI, it wasn't a perfect Docker image, but it was a great way to get started. So that could be the goal for an application that isn't being actively developed. You might just want to run it in Docker to get those efficiency and portability and security benefits. Or if an application is being actively developed, moving it to Docker might be the start of a modernization program to take features out and run them in different containers in the same way that I showed you with my handlers running with a message queue in between. Okay, and the last thing is what to do next. There are 2 things here. So Docker Labs up on GitHub, we have a whole bunch of self-paced labs. You can go and follow the instructions and try this stuff out for yourself. There's stuff on Windows, ASP.NET, there's SQL Server, there's a whole bunch of stuff. And our next big conference is DockerCon Europe, which is happening in October in Copenhagen. DockerCon is an awesome conference, so you should definitely come to that. And you should follow me on Twitter. So I'm Elton Stoneman on Twitter, and I tweet about this stuff all the time. So thank you very much for joining.
Thank you, everyone. This concludes today's webinar. A reminder that this session was recorded and a copy will be sent out to you. Please be sure to register for upcoming Docker webinars at docker.com/webinars, and also check out docker.com/events for customer-facing webinars and events. We thank you again for joining us and hope you have a great day. Thank you.